Hi everyone, Mrs. Below here. In this video, I'm going to teach you how to write an electron configuration. Now, hypothetically, you could use this to help you with writing an electron configuration, but you're going to have a question on a test or a quiz where you don't have this diagram for every single question and you just have to write the electron configuration. So I'm going to teach you how to use your periodic table in order to do that. First, I'm going to move helium over here. So this looks like your periodic table that you were given in class. And I'm going to go over how to write the electron configuration. So this is another way to represent those electron clouds that are found around an atom. So to use our periodic table to do that, we're going to read it like a book, left to right, one line at a time. So I would start here with 1s, and then I'm going to count how many boxes there are, because remember, these are neutral in charge, so each proton is equivalent to an electron. And so each box represents like the atomic number, which represents a proton essentially. And we're going to do this until we get to the element we want, which in this case for the first example is carbon. So I'd go 1s and then I count the boxes. I'm just going to cross them off as I go. 1, 2. Okay. Then again, this is crossed off here. And then I'm going to go to the next line. So now I have 2s, and I'm going to count the boxes. 1, 2. 2s, 2. And this makes sense because in an s orbital, if you remember from the activity, it was that sphere shape. You can only fit 2 electrons in it. So that makes sense that there's a 2 with that. These are representing the number of electrons. And this is representing the shape. And then, of course, the energy level, which are the numbers. And then we're going to go over here. And we have 2p. And we're just going to count to the element we want, which in this case is carbon. 1, 2. So we would end with 2p2. And this would be your final answer. This is the electron configuration for carbon. All right, let's do a few more examples where we have to go a little bit farther down on our periodic table. And again, you're going to start to see a pattern here, and you're going to get kind of used to this. So again, 1s, and then I count 1, 2. Okay, again, helium's crossed off over here. We go to the next line. 2s, 1, 2. 2s2. And then we're going to go over here. 2p. Now I got to keep going until I get to chlorine. So I'm going to count the boxes. 1, 2, 3, 4, 5, 6. And that makes sense because in a p orbital, if you remember from the activity, the dumbbell shape, there were 3 of these. You could fit 2 electrons in each, so 6 electrons total. And then I'm going to go to the next line. So 3s. And then I'm going to count 1, 2. 3s2. Okay. And then I'm going to go over here. And again, we're going to count until we get to chlorine. So 3p. And then we're going to count 1, 2, 3, 4, 5. And this would be the electron configuration for chlorine. All right, so let's do another example where we have to go through the D block. So again, going farther down here, cross off helium, move it over here. It's because helium has an s orbital shape. So we just temporarily move it over here to be with the s block. All right, so again, we have 1s, 2. Go down a line. 2s, 2, 2s2. And we're going to go over here. 2p, 1, 2, 3, 4, 5, 6. 2p6. We're going to go to the next line, 3s. So 3s and then 1, 2. 3s2. Now we're going to go over here. So now we have 3p, and then again, we got to keep going until we get to copper. 1, 2, 3, 4, 5, 6, 3p6. I'm going to go to the next line. Now I'm here, so 4s and then 2. 4s2. And now, yes, you are going to go here next. And I know it's 3 and you're like, well, why are we going down? The elements that are here in the middle don't always follow the same rules as everything else. So now we have 3D, and we're going to count until we get to copper. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would end in 3D9. And this would be the electron configuration for copper. Next, we're going to go all the way to iridium, which is going to have us go through the F block. And I'm going to explain what that is. All right, so again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now we have 3D, and if you count, I'm just going to cross this off as I'm going like this, and now we're at 3D, and this is 10. And then note that there is, I'm going to highlight this, there's a 4 here, okay? So now it's going to be 4p, and then we're going to count 1, 2, 3, 4, 5, 6. 4p6. And now I'm down here, 5s, 5s2. Just going to cross that out, 5s2. Now I'm here, 4d, and then again there's 10. Okay, now I'm here, you see that 5 here. So this would be, move this over, 5p6. Now I am here, 6s2. Okay, so this is the tricky part, okay? I'm going to zoom in here. All right, so most of you after 6s2 would probably want to go here to 5D and then get to iridium. However, you're going to notice that here it says 57 through 70. So that is these elements here. So technically, those are in that space, okay? Let me go to my periodic table. Okay, so if I go to the periodic table and I put it in this version, now you can see that, okay? So we don't represent the periodic table like this because it would just take up way too much space. So normally we represent it like this by putting this F block here at the bottom. So technically after 6s2, we have to go to here, which is 4f. So this is technically 4f. So this would be 4f. Okay, so that's where I am. Kind of like taking a detour. It's like we're here. We're going to go through here, and then we're going to continue back up here. So this would be, so we did 6s2. So now I'm going to do 4F, and there are 14 boxes here. 14. And then I'm going to continue. So it's kind of like we went this way, and then we're going to continue back up here. So then I would end with 5D, 1, 2, 3, 4, 5, 6, 7. And then this would be the full electron configuration for iridium.